Welcome to what I'm fairly sure is the second last video in the rotation and torque topic. In this video we'll be having a yarn about torque and Newton. In particular, what we will be looking at is Newton's second law for rotation. And what we will do in this video is essentially just another translation from a linear system to a rotational system. So if you cast your mind back to the forces topic, you will remember that Newton's second law is that the net force is equal to the mass times the net acceleration. And we are now looking for how we can interpret this in our rotating system. So for an object undergoing rotation, as we saw in the previous video, the force that matters, so the force that causes the torque, is the tangential force. So Newton's second for the tangential force states that Ft is equal to mass times the tangential acceleration. We also know that the tangential force is related to the torque by this equation, where r is the radial distance from the axis of rotation to the point where the force is being applied. Combining these two equations, we get that our torque is equal to the mass times the tangential acceleration. And our tangential acceleration here is still a linear quantity, so we'd like to change that to some rotational variable. Thankfully, we also know from previous videos that our tangential acceleration is equal to our angular acceleration, alpha, times r. So when we substitute that into our previous equation, we find that our torque is equal to mass times alpha times r squared. And we can make one further simplification, or find one more relationship. We know that the quantity mr squared is our rotational inertia. So, in terms of angular variables and rotational motion, the form of Newton's second law, F equals ma, can be written as our torque, our net torque, is equal to I alpha. So before we consider ourselves finished, we also know that Newton's second law can be written in terms of the momentum. So it's equal to the change in the momentum over time. And so to convert this into rotational variables, we know that our torque is the rotational equivalent of our applied net linear force, and we know that curly L is our angular momentum. And so substituting those values in, we find our second expression of Newton's second law in terms of momentum, and that is that the net torque, is equal to the change in the total angular momentum over time. And there is a much more convincing proof of this, so where the dots are filled in with various equations. And that proof follows much the same idea as the initial proof of Newton's second law in the forces topic, and I have left that to your lovely selves in the first question after this video.